Okay, 1.3.1. Today, the main point is you are going to be introduced to a whole bunch of functions, and then they ask you things about these functions. I'm going to start with the things about the function. You already know several. Like, for instance, you know the absolute value. If I asked you about the absolute value function, I'm just going to graph it real quick here. And would you agree that it has an x-intercept? Also known as a root, also known as a zero. Do you get that it's that spot right there? And what is the x of that spot? Zero. Okay, so that's the x-intercept of the absolute value function. It's also the y-intercept. It happens to hit it that spot. All right, so it's got an x-intercept, it's got a y-intercept. How about this? They might ask you, is this function continuous or not? Yes, it is. I'll give you an example of a function that's not continuous. Because when you're drawing it from left to right, you would have to lift your pencil up to finish the graph. Remember this guy? I don't know if you remember this function or not, but it is called the 1 over x function. That one, does it have an x-intercept? No. Does it have a y-intercept? No. Never touched the y-intercept either. And no x-intercept, no y-intercept. Therefore, does it have any roots? No, because they are the x-intercept. Does it have any zeros? No, those are the x-intercepts. Roots, zeros, x-intercepts, you got to get the idea those are all the same. Okay, y-intercept different. Still doesn't have one of those. Is it continuous? No, because it's got a break in it. You could not write it from left to right all at once, without lifting your pencil. Now, could you do that with a parabola? You make a parabola continuously as you go from left to right? Yeah, so that is a continuous function. This other one was not continuous. We can call it discontinuous, but it's not. All right, next thing, domain and range. The domain and range on this one are kind of trickier than average. They're going to ask you about all these functions. And the domain on this guy is from negative to positive infinity, kind of. But my newer way of writing domains is put them right on the x-axis. Let me show you why this isn't just from negative to positive infinity. It works in the areas I've drawn in red here. But it doesn't work right there. You can never hit zero. So do you get that this is the graph of my domain? And then if I just write that in interval notation, I'll have it. Everybody try to write the answer for as an interval notation. And turn it my way, and I'll tell you if you did it right. You're supposed to write it with parentheses and stuff, and you do it. Good. Yes. So far, good. Good. That's 7. Not practice. Because practice is quiet. Yes. 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 Oh, wait a minute. Somebody had a 1, I think, and now that I'm looking back at it. No, there should not be a 1 in your answer. Yes, except for yes. Yes. I know you wrote them on different lines, but still. What did you say? Yes. Okay. You should have said from negative infinity to 0, and then it stops working. That's this part right here. Then, continuing with, it starts working again after 0 and infinity. There we go. There's the domain. The range, which on this one, ironically, probably not incidentally, would be the same thing. Okay? Because you can do the range on the y-axis. You get how it goes forever this way, but it can't hit this spot, and then it goes forever this way. So the range on this thing is the exact same. Negative infinity to 0, union with 0 to 6. Okay, let's domain and range. Let's talk about the 12 major functions that you have to know. These are the 12 Precalc functions. And these are 12 functions that you already, many of them you have already seen, but you may not know. I think you're going to know 6 out of 12. Like, okay, so let's go fairly fast here, and I'm going to give you an example for all 12 Precalc functions. All right, I'm going to take this graph and draw them all on here. I want you to make 12 separate sketches, and I want you to label them all. because you know later it's going to say in the homework, make an example of the greatest integer function. And you're going to go, I don't know what that one is. And we don't have a textbook for you to look it up in. Look it up in your notes. So, good notes for you. Good. 12 good graphs here. All right. Pause for a second. Okay, so I am starting with x squared. That's number 1. Okay, and it doesn't have to be number 1. But there's another one here coming up called the y equals x function. I mentioned that one before left, right? So you got that one. And that would be a line that runs like this for y equals x. It hits all of the spots like what 1, etc. Okay, good. The next one is x cubed. I hope you know a few parent points on that. Again, I don't expect you to know every point that hits x cubed, but you should know some classic ones like 2, 8. So here's your x cubed function. You guys address that one? Okay, good. The next one I'm going to do is absolute value function. Absolute value kind of looks like this. Let's see the shape. All right. Goes forever in both directions. So is it continuous? Yeah, would you be able to do this domain and range? Pretty easy. Domain would be negative, domain would be positive. Plus the range. 0 to remember these go in both directions. Okay, next one is the 1 over x function, which I graphed just a few minutes ago. Remember the key is these two spots, and then from there you can just get closer, or touch these, which are the f. Okay, that's the 1 over x function, and then the last one's the square root of x function. So, was that really thick? I think it was. We good? Okay. By the way, is this one continuous? Yes. I just have to say, from when you started making the graph, you can keep going without a gap, right? I'm sorry with that. I thought it was my very first one. All right, I'm going to show you something. I'm going to get back in time. One of the beautiful things about it. Yeah, I'm going to go forward. This is the first one. I'm going to go back in time. There. Come on, where is it? Where is it? Where is it? Where is it? Get close. It looks like right there. Busted. Yes, and you're right, kind of. Because when I came back, I didn't get it. All right, listen. We need a few more parent functions, and these are the ones you don't know already. So pay especially good attention on these. All right. This next one is called the exponential growth function. I know you've all heard of exponential growth. There is a specific function for it, y equals e to the x. You will learn a lot more about what e to the x is, specifically what e is. E is a number, just like pi, and it's about 2.7. It is a number that goes on and on and on and never repeats. It is a very special number, but you'll learn about that more in calculus. Well, exactly why it's special. But in Precalc here, we're just going to start with telling you it's about 2.7. And when you graph this, about 2.7 to the x, that's called the exponential function. Now, it never crosses 0, so there is an asymptote line. That's important. Okay, that's the e to the x function. That's the 7th function. Question? All right. Let's do another one. This one, next one's called the basic logistic function. Basic logistic. And the basic logistic function has two asymptotes. One along the bottom here at 0, and then another one, and I'm going to like put it at 5.5 just because I want to make the point that it isn't always at exactly any given number. You can pick a number to be its maximum. So here's how it looks. L for the limit, where it's maximum. And in this case, the way I'm graphing it, the maximum is going to be 5. And it starts out just like the exponential function. You get that, like, from here to here, it's like looking just like the exponential function. And then all of a sudden, the thing like rounds and starts slowing down. And it gets lower and lower, and it never will cross that asymptote. This function has an asymptote on the bottom and on the top. Now that means it's bounded. New word. You ever heard of boundaries? It's like it has boundaries on the side. As in it's bounded on the top and the bottom. You can't go any higher than this or any lower than that. So it's bound. All right, it's also continuous. Goes forever without having to raise my pencil as I go from left to right. All right. So that one was called the basic logistic. Oh, I'm sorry, I didn't read the rest of it. Okay, I did the rest. 1 plus e to the negative. That's the 8th function. The 9th function we're about to do is called the natural log. You studied logs last year a little bit? All right, good. That's good question. All right. This next one's called the natural log. And would you agree that a log is just a tree that is basically not upright as a tree anymore? It's kind of like blown over. Pretty clear what I mean. Like this tree that was growing, it has roots, and then all of a sudden it got blown over. So like, you imagine a tree for a second. Okay. Anyway, that is the log function. So it looks like this, over like that. Now it's got an asymptote, but it's not this way. A lot of people think there's an asymptote that way. There is not. But there is an asymptote going this way, right up the y-axis. Can you shut that door for us, please? I know people don't think this is a classroom. All right, this log, we're going to do so much more with this. Here's the equation y equals ln of x. ln means log base. Remember that other equation? Log base. I'm going to write it that way. You'll learn a lot more about logs this year than you did last year. All right, you need to be writing these things down. There's 12 of them. I know you don't have these all memorized. That was our 9th one. Our 10th one. Our 10th one is a special one called the greatest integer function. And what it means is basically it's a function that keeps going up, but it rounds to the greatest integer. So, for instance, until it hits the next number, it's 0 until it actually hits 1. And then it becomes 1, and it stays that way. I'll give you something that is like this in the real world. This is how we handle birthdays. Remember, this is like time. Okay? And for a newborn, you usually don't talk about how many years old they are. You talk about these months, right? But after they turn 1 year old, then you start calling them 1 year old all the way until they hit what? Can you call somebody who's almost 2 years old a 2 year old? No, we don't round it that way, do we? We wait until they actually hit 2, and then we call them a 2 year old all the way until they're a 3 year old, etc. So it's sort of like the age function. Right? This is officially called the greatest integer function. It goes like this: y equals int x. It's a good question. Can you draw this thing without the thing? So you have to lift your pencil up so it's not. Technically, there's a little empty spot here. You don't have to draw it. That way, it passes the vertical line test because right here, it goes through there, it only touches once. Make sense? This has to pass the vertical line test because otherwise it's not a function. All right, the last two are sine and cosine. That'll make our 11th and 12th function. Y equals sine of x. And you need to memorize this sometimes. You might as well memorize it now. Sine goes through 0 and goes up. And from there, it's a wave. It just keeps going forever and ever. And it goes both ways. Get the idea? Sine is a wave that goes forever in both directions. It goes through 0. And the highest it ever goes is 1, the lowest it ever goes is -1. So now, if it's going to really continue forever, this way and that way, you get its domain is from negative to positive. How about its point? -1 to 1. That's sine. So now I'm going to save time and make a point by doing cosine this way. This is not cosine, but all I have to do is shift it over. I'm going to shift it this way. Okay, now it's make cosine. You get how it's also a wave, but it doesn't go through 0, 0. It goes through 0, 1. So cosine is at its peak at 0. And then it goes down all the way down to the valley and then up again. So cosine is a lot like sine. So today we're just going to ask you a ton of questions about these functions. That's really your main assignment is like they're going to say, what's the domain and range of the sine function? We just talked about that one. How about cosine? Domain's same as before, right? Negative 35 infinity. What about its range? Exactly the same. Does it have the same y-intercept as cosine or as sine? Yeah, sine and cosine have different y-intercepts. This one hits at 1. The other one hits at 0. How about x-intercept? This has an unlimited number of x-intercepts. Get that? Keep touching the x. Here, and it kept going. It was touching. So unlimited number of x-intercepts. All right, let's watch. All right, last couple thoughts. Is this odd or is this an even function? Think about its symmetry. Does it have even symmetry? Like that even symmetry has that line right down the middle. Does this one have that? For every point, now I might have drawn it slightly imperfect, but you get that for every point that's over here, there's another one exactly over there from it. And if I pick this spot here, there's another one exactly over there from it. All right? Now let's look back at what sine looks like. Sine, see if sine is even or odd. Sine was the one that started at 0 and went up. Okay? If I keep going with it, it's down like this. Okay. Now, can you tell it does not have even symmetry? Now, does that mean it's automatically odd? No. But we can look at the pattern and see. Is there a spot if I go through the origin? Is there one that matches up with it exactly? Yeah, let's try that again on another spot. Let's say like right there. Through the origin and keep the pattern going, and is there one that touches it? Oh, yes, there is. You get how that has odd symmetry. That's hard for a lot of people to see. I'll take another point that's a little more extreme. That guy. Through the origin. There we go. Spot on it. And there's a reflection across the origin. So this is odd. Alright. That brings us to the end. You know everything you need for the 12 major functions. And some of the things you need to know about the domain range and the final set, all that kind of stuff. I'm going to pause for just a second before I end the video just in case, make sure I didn't forget. So let's look at the first couple thoughts that you'll want to hear. Identify which of the 12 basic functions fit. The two that are not continuous. Name one of them. The 1 over x. Yep. Why? 1 over x, because remember the graph of that guy? It looks like this. Okay, it has a gap in it. All right, what's the other one? Yep. And that function looks like this. It has like little, like the age function. You're 1-year-old until you're a 2-year-old, until you're a 3-year-old, etc. And that one has gaps all over. All right. We're going to do odds here for a while. 4 functions that are odd. All right, I told you one of them. Sine. You'll have to look through it, find out more of them that are odd, etc. All right, that's all I got for you for today.